My name is Johan Andreasson. I'm head of strategy and innovation at Modelon, and I'm here with my colleague Johan Windahl, who is product manager for Modelon Impact. And this will be the topic of our vendor session. So I just realized that it looked similar like 20 years ago, or a little bit more. Modelica conference in Lund 2020, we had an auditorium like this. It was about the same amount of people. Sorry for that. And of course, there has been a lot of cool things happening with Modelica over the years. The conference has grown from the initial whatever it was to maybe 300 or something in 20 years, a little bit more. We think that Modelica deserves better and more. It's a great technology, and we want to see a much more broader adoption of Modelica than what we see today. What Modelon is doing is to provide industry-grade solutions, and we do that based on open standards. And what do we mean with industry-grade? Yeah, of course, we have a long history, over 20 years now, of developing models and making sure that they actually give the predictions that the industry wants. We also think that for Modelica to become the success it deserves to be, we of course need to continue to work on it. Yes, there are some things that are complicated and can be improved in Modelica, but we do really think that the way forward is that we stick together as an organization and that we work to bring this forward. We also think that, yes, FMI is another great thing. Of course, we adopted that as soon as it was invented, so we are FMI native. But we also think that there are other things out there that we need to leverage in order to provide something that is truly useful for the industry. That means that more people can actually access Modelica directly and indirectly. And some of these topics are Python. There is a lot of useful things in Python that we leverage. We also believe that open APIs to what we provide is a key thing. We also see, and we'll actually do a little bit of demo to show that, but artificial intelligence is a great way for us to actually make Modelica more accessible to a broader audience. We also leverage open web technology to make sure that we can build this. So with that, I will leave over to Johan Windahl to show a little bit more hands-on what this actually means.
Thank you, Johan. For those of you that are not familiar with Modelon Impact, so Modelon Impact is a platform for both application, usage, and creation, meaning that we're spanning over many different user groups that have different goals and also needs. From Modelica developers that's writing Modelica code, creating libraries, all the way to the right to the deployment users that configure parameters in a simplified view, such as our Excel add-on or app mode. And we're working broadly, improving the product, and I will cover the highlights that roughly go back 1 year ago and all the way to the bleeding edge, what we're currently working on at the moment. So we'll start with the Modelica developers. For our Modelica developers, what's important, or for all that's writing code, is to have a good code editor. So we're currently improving that, and we do that in 2 different ways. So the first way is that we updating the existing ones that we have integrated fully inside the tool. So we have modern usability functionality such as minimap for easy navigation, comment panel with a lot of commands, better find and search, etc. But we also, and I think in general that will be good for many users that maybe go in and do minor tweaks, maybe change correlation and so on. But for users that may be coming from the Python world, I don't think this will be really exciting for them. They were expecting more functionality. So our second approach is also that we doing an integration to our version of VS Code. And in order to have a good user experience there, we need to have language support. And if you're writing in Modelica, you need to have a Modelica language extension. And this is something that we have developed. So I will show a little bit demo here, recorded video of how it could look like. Before doing that, my personal what I like most is the instant semantic error check, which means that as you type, you can get direct feedback if you have errors. So let's start here. So the integration is that you start by clicking a code button, and that takes you to our version of VS Code. This will open up the model, and I will just introduce a few errors here, so adding an extra S here for the port. We don't have any such component, and it will automatically get feedback that this is missing. We can't find a declaration of that. It can also detect if our equations and variable doesn't match, so just adding one extra equation here. So it should trigger an error. And we'd also take benefits of all the other good functionality in VS Code, such as peek view. So you can hover over a component, quickly see the code without having to switch context. So to summarize, we think this is a good addition for our Modelica developers and also for our Python developers that don't need to switch code editors. Moving over to the user interface and talk about customizable user experience. We believe that Modelica is the best language to write models for. But for workflows such as execution and experiments and post-processing, Python is a great choice. So what we have done is that we have integrated direct native integration to Python, which means that you can extend the experimentation capabilities with your own calculation. And this is something you can see to the left here. So the Python interface consists of two parts. One is the user interface, and the second part is the part that executes the Python. And we have done improvements in both places. So we have support for new UI elements for results and data files. And on the execution side, we support orchestrating of other custom functions, which means that it can send them and be calculated in parallel. And this is an example that our newest library is the calibration library. So it can be used to calibrate models against measurement data. And it also generates an automatic report. So just one example of what you can do yourself. The second way to customize a library is with apps. So you can distribute them together with your library. And this is an example that we did in a research project where we created a reduced order model. So in total, I think the summary here is we think that Python is a great complement to Modelica, which will make the libraries more powerful. Moving over to applications. And the first thing is that we see a growing ecosystems of the libraries that Modelon Impact support. Modelon itself has a lot of different libraries, but the vision has always been from the start to be a true open platform. And not just for the open source library, but also for commercial libraries. So the first news is that we have integrated support for the buildings library, and a few weeks ago we had the first yearly course done with Modelon Impact. The second thing is we see industrial usage with the TIL library. So Danfoss is an example that use it together with app mode to close the gap between simulation and sales. And we also support other libraries such as the process system library by TLK Energy, HVAC library by XRG, and Blue Energy library by EA Systems Dresden. And the question mark is because we would like to grow this further. So if you have any libraries that you would like to see in Impact, please come and talk to us here during the conference. The second news is around emerging technologies. So besides the standard industries that we're working in, like HVAC, automotive, and so on, we also support data center. And we've been working with one of the leading players there, building up a solution, and we have seen great results coming from that, be able to save a lot of energy with better optimization. The second part is also that we support another emerging technology is hydrogen. And we can model or solve engineering questions on how should the storage be, how should the refueling be, and so on. So in total, we now support a lot of different applications. Moving over to the big news that we have on the user interface, we have two different new user interface, one for experimentation setup and another one for post-processing. So with experimentation, we have now a dedicated user interface to explore the design space using either parameter sweeps or statistical experiments, so-called design of experiments. And the good thing is that the user don't need to think if the parameter is structural and require a recompilation, or if you're gonna distribute that on different cores for execution. This is taken care of automatically. For the analyze part, there's a new user interface, and it contains several different plot types, from standard line charts to scatter plots to histogram and so on. And it also comes with good usability improvements, such as synchronized zoom for all the plots, and also a functionality where we can compare sets of different results against others. So for example, a use case could be that you have two different variants of a heat pump, and you want to compare those variants, but not just over one single operating point, but over multiple, for example, in hot, cold, and humid conditions. And this is something that we can do easily now with the plotting. Collaboration and integration support is an important part of our platform. The goal is that we building something that supports teams and organization, and workspace sharing is a central part there. It meaning that we cannot just share, not only sharing the models, but we share everything that's needed to reproduce the result. So that means the dependencies of your libraries, experiments, all down to the nitty-gritty details if you have set a compiler flag. Another important piece of that in order to reach the organization and reach maybe stakeholders and manager that tend to like Excel is that we have an add-on where you can create, set up experiments and use essentially Impact as an execution service. And the last part is the learning piece. The goal is to accelerate the learning and be productive with the tool. It can be quite challenging with modeling and simulation that is quite complex. So what we offer here is a help center available online with a lot of getting started materials. You can find all the release notes, etc. And what's new there is that we have new video tutorials from the most basic things to more advanced topics. Another thing that we have not yet launched, but we are in pre-launch mode, so we're looking for pilot customers to try it out, is a community forum, where you can ask peers about and Modelon personnel about any type of questions. And the last thing is around AI. So we're wondering, can AI really accelerate the learning and the productivity? But it is something I leave for Johan here to talk about.
Yes. So it's time for a demo, don't you think? We haven't pre-recorded this one, but I think we should be good anyway. So this is Modelon Impact. It's running in a web browser. And for those of you who are familiar, you probably don't see much difference, but except that there is this little AI assistant button down here. So the point here, what we are trying to achieve with AI in this context is to make sure that we actually help people get started, right? We all agree that Modelica is great, but we need to get more people over the threshold to get started. So the first thing I would do as someone new is that I want to get some help on how to even get started. So let's say I want to design a heat pump for my 200 square meter house. And what we're doing here with AI is effectively giving the AI access not just to general knowledge, but actually also, you know, what libraries are out there, what can you do with them, etc. So that it's actually helping me to sort through a wide range of different libraries to give me a suggestion on effectively how to start. So I think we can also do like this, so you see better. So you see it starts to add a lot of stuff here and suggestions, but these are actually things that exist, right? So it's not fabricating this, which it's not too unusual. So let's say that we take this first advice and start with it. And what it has done now is effectively, it has created this model for me. So I have it here. And then the next thing I would probably want to do then is, I have some results and I would want to know, okay, I'm not really familiar with this model. So I get some help to understand, okay, what should I look at? So can you please suggest a performance indicator to plot? And now what it's able to do is actually to look at the results and suggest something based on what I asked. So now I'm not the best guy on heat pump, but even I know that, yeah, okay, this one, first one, coefficient of performance seems pretty nice, right? So I can take this one. And again, since it's actually not fabricating anything in this case, it's actually there to plot as it is. Then, suppose I have this model, or I'm building a model, and for some reason it's broke. So if we now take this model and we're compiling it, and yes, it will take some time to compile, but then, as you all know, since you're experts and you saw what I did to break it, it's easy for you to figure out what is wrong. But if you just open a model like this, it's much harder to know, and especially if you're new. And then you get this classical compilation failed. And again, you can read through if you're an expert, but I don't want to do that. So what is wrong with my simulation? And again, since we have know-how at Modelon and other, from experiences, we can actually give some hands-on advice on what actually to do with this. And in this case, so the recommendation is, let's see, here, review the boundary conditions. So it's actually, in this case, detecting then, based on the error message, what I should do, and say that, oh, you should probably check so that it's actually properly connected. So with that, I can actually then connect the model and get it running again. So just a very, very short preview on how we think we are, how we can actually use AI then to lower the threshold for people that are not familiar with Modelica and addressing various things such as finding the right component, also understanding what to plot in the model, even if it's not really explicitly told by anyone, and also that we can get a companion when things go south. So with that, yeah, let's go back and summarize a little bit. So Modelon Impact is cloud first. It's run from the web UI. Everything is accessible there. And we really want to stress that we firmly believe in Modelica. We firmly believe in FMI. And we think that complementing with Python is a great thing for us. And we also see then huge value of exploring AI and bringing that tighter and tighter into the offering, because it looks very promising in order to reduce the threshold for new users. So that in a couple of years, when we sit here there will be much more people attending Modelica conferences, and there will be much more people using Modelica all over the world. Thank you.